this lesson, we are going to learn how to determine the volumes of a substance or the substance using the methods called water displacement. Now let's look at the name of the method. It's water. So of course we are using water because water is very stable, is not corrosive, and is safe. And displacement, think of the word displacement. So let's go back and look at this picture right here. First of all, we have water, and the water will be in a graduate cylinder or any container. So what we have here is an object or a substance. We want to measure the volume of this object very quickly, and one way we can do is using the water displacement methods. And how it works is basically you take the object and you drop in a graduate cylinder that contains water. Notice how there is a difference in the two readings, and that is because of the object here. This place basically gonna take over the space right here and gonna push the water up. And that difference from here to there is the volume of the object. So let's go back to the definition again. So in this case, the submerged doesn't mean it has sunk all the way and submerged by the liquid, in this case water. Displace the volume, which we see that right there, push the water up because this object has volume, so it will displace that volume right there, and that volume is equal to the volumes of the object. And think of this in terms of math. Basically this will be your final reading, that is result from adding from, that is result from adding the object, and this will be your initial reading. And once we figured out the difference, right, which is a basic equation, we take the final minus initial, that will give us a change. So we take final minus initial, that will give us the difference, which equal to the volumes of the object. Right there. Let's do an example problem. Here we have determine the volumes of aluminum in the graduate cylinder. So how does it work is that I have two graduate cylinders. One is before adding the substance, and of course you don't want to see the substance at all because right on the bottom, sink all the way on the bottom. So in this case I have our reading 30 all the way to 40. Of course each one will be 1, so we have 31, 32. But I have to estimate on the last digit, which is not there, and it is 0 because on the line. So that is our initial reading, and the unit of course is ml because we measure graduate cylinder. Then over here, after we add in the aluminum, we have 30, of course this will be 35, so 36, 37, and 38, and that gives us 38.0 because this has to be estimated. So what we have here is, again, going back to the question, take the final minus the initial, give us the difference, which is the volumes of the object. So to find the volumes of aluminum, all we have to do is take the final, which is 38.0 ml, minus your initial, which is 32.0 ml, and we have our difference in terms of 6.0 ml. Notice how we subtract, right? We keep the least decimal place, but both of them have one decimal place, so our answer also has one decimal place as well. Now, the volumes of what? In this case, specifically, is the volume of water that we're looking at. But we also know that the volumes of water being displaced is equal to the volumes of the object. So this is also equal to the volumes of the object or the substance. In this case, is aluminum, 6.0 ml aluminum. And that's all we have to do for this type problem. Let's try another problem again. Determine the volumes of aluminum in the graduate cylinder. So we have two graduate cylinders again, before adding the substance, which is aluminum, and after we add it, we have a change in the reading level. So this is our initial. In this case, we have a 10 millimeter graduate cylinder. So here I have 4, and here I have 5, so each one of them must represent 0.1. So we have 4.1, 4.2, 4.3, and so on, but the line is right there. This is the meniscus level, so if this is 4, this must be 3.9. And I know that the line really represents 0.9, so I had to go to a smaller digit, and this one is 0. That's why we estimate it. Let's go up here. We have 9, so it's 9.1, 9.2. Here I have 9.1 for this line and 9.2 for that one. So what's the distance between those two? Of course, 9.15. And again, let's go back and look at our difference. Basically, you take the final minus the initial, which is 9.15 ml minus 3.90 ml. And that will give us the volumes of aluminum, 5.25. Notice how this is 2 decimal places and this is 2 decimal places. Therefore, this must also have 2 decimal places as well. So ml of H2O being displaced, which is equal to the volume of aluminum as well. Isn't that easy? Now, why do we care about finding the water displacement of an object or a substance in the first place? That is because we are connecting to the formula of density. First of all, to determine a density, you pretty much need 2 things. You need to determine the mass and the volume. We just did that. We can use a gravity cylinder and water to find the volume of any object. So we figured out the volume. And if you notice, this is the same one that we had before here. Notice how the same reading, right? So we know the volumes of aluminum is 6.0 ml. And specifically, aluminum. Okay? But what about the mass? If we go to the problem and say, substance aluminum that displays the water in the gravity cylinder has the mass of 16.2 grams of aluminum. What is the density of substance? Before we move on, let's look at a specific example. In this case, I have a gravity cylinder, 10 milliliter. Notice how there are no substance here. And the reading is about 5 right there. You can see that right there, right? So, in this case, I don't have aluminum, but I have copper. Look what happened when I added in the copper. You can see that it is increasing the volume. And notice how the copper displays all the volumes down here. So now our reading is about 7 something, which that's not how you're supposed to read the reading. But you can see that there is a change in the volumes of the water. So you can see that there's a change in the reading level. And that is water displacement. And we can use this method to find the density of copper we want to. So keep that in mind. Now let's go back to this. What is the mass of aluminum? Of course, we're finding the density of the same substance, aluminum, so we have to look for the mass of aluminum, which is given to us. So in this case, the mass is 16.2 grams of aluminum. And all we have to do is plug this in. Divided by 6.0 ml aluminum. And when we divide, we keep the least number of sig fig. This one has 3 sig fig but 1 decimal place. This one has 2 sig fig but 1 decimal place. We don't care about decimal when it comes to divide or multiply. We care about sig fig. In this case, is the least one, which is 2. So our answer must have 2 sig fig. Let's plug this into a calculator. We have 16.2 divided by 6.0. And we have 2.7000. So how many sig fig do we keep? In this case, our least number is 2, so we're going to keep 3. That way we can round it if we need to. So 2.70. But if we round it right here, that 0 wouldn't do anything to the 7. So you have 2.7. That's our number. And now let's plug in the unit. Does the unit cancel each other out by simplifying each other? Here I have grams of aluminum. That is a completely different thing comparing to milliliter of aluminum. So therefore, we just copy down the unit. Grams of aluminum divided by milliliter of aluminum. But how many exactly? Of course, this one is always 1 milliliter. Okay? Keep that in mind. When we simplify, a fraction is always equal to 1 on the bottom. Let me prove that to you. For instance, I have a number as simple as 10 over 5. Let's look at this. What's 10 divided by 5? That gave us 2. What has to be here in order for this to be 2? Of course, 1. Anything multiplied or divided by 1 is equal to itself. And that's the beauty behind of 1. So always know that this is 1 right there. Let's try another problem. How about that? In this case, I have the same reading as before. Notice I have the same problem right there. So the volumes is determined. So let's go back to the reading. The substance aluminum again that displays the water in the gravity center has the mass of 14.2 grams of aluminum. What is the density of this substance? And again, the density is equal to mass divided by volume. And I figured out my volumes right there already. 5.25 ml or milliliter of aluminum. So this is 5.25 ml aluminum. What about the mass? The mass is given to us right there already, which is equal to 14.2 grams of aluminum. Now let's plug this in. Divided by 5.25 milliliters of aluminum. And we plug this into a calculator. 14.2 divided by 5.25. That gives us 2.70476. And how many do we keep? Again, this is dividing or multiplying. We keep the least number of sig figs. This one has 3 sig figs. This one has 3 sig figs again. So our answer must also have 3 sig figs. So I'm going to copy down 4 sig figs. 2.704. And we round to keep 3 sig figs, which is right here. That's the first, the second, that's the third. The fourth wouldn't do anything to the 0. So therefore we have 2.70. And what about the unit? Of course we just copy down the unit because they don't cancel each other out. Grams of aluminum on top divided by ml, milliliter of aluminum on the bottom. How many? Of course is 1. And that is all we have to do.